In this video from LearnElectrics, we will clarify some of the confusion regarding RCDs and their use. The often asked question is, what is the difference between an RCD and an RCBO? Well, the answer to that is that RCD is the name of a group of protective devices which includes RCBOs. An RCBO is in fact an RCD device. Taking a look inside most modern consumer units, we will often find a device marked RCD that is protecting part of the installation. This is actually an RCCB. Let me explain. RCD is the family name, and in this family we have several similar but very different devices, including RCCBs, RCBOs, MRCDs and CBRs. In this video we will concentrate on the two popular devices, the RCCB and the RCBO. The RCCB is often marked as RCD as shown on the left, and if we talk about RCDs we are really discussing RCCBs. It's just one of those peculiarities of the electrical trade. And there is the RCBO, shown on the right and identified with the letters RCBO. So the RCD is the family name. It stands for Residual Current Device. The RCCB is a residual current operated circuit breaker without integral overcurrent protection, often called residual current circuit breaker. Notice those words, without overcurrent protection. Whilst the RCBO has the full title, residual current operated circuit breaker with integral overcurrent protection, or simply called residual current breaker with overload. Again, the key words are with integral overcurrent protection. It comes with this built into the device. If we look inside any RCD type device, we will find that the basic RCD part is very much the same. There is a toroidal ring made of metallic alloys that is very sensitive to current changes within it. Around this are wrapped two coils, the phase or line coil and the neutral coil. As current flows along the line coil, it induces a current to flow in the toroid. If the neutral current returning from the circuit is the same as the line, for example 5 amps in and 5 amps out, then an equal and opposite current is induced in the toroid. These two opposite currents cancel each other out, and the result is that the sensing coil, the third coil, does not sense any change. Because the sensing coil detects nothing, the trigger mechanism does not operate and the switch contacts remain closed. Nothing happens. Let's plug a standard 13 amp kettle into this circuit. 13 amp flows in and 13 amps flows out. There is no leakage current and therefore the RCD does not trigger. This is a normal healthy situation. The kettle is getting old now. A little corroded in places, but it still boils the water. There's a slight leakage from the heating elements to the earth, but nothing to worry about. At 10 milliamps or 0.010 amps, the sensing coil will detect this, but it is below its trigger threshold and so it does nothing. A few months later, however, the kettle corrosion has become worse. Our customer turns the kettle on and 13 amps flows through the line and down the neutral as we would expect. But 50 milliamps also flows down the earth cable as leakage current. Where has this 50 milliamps come from? It must have come down the line conductor. So the line is actually carrying 13.050 amps and the neutral just 13 amps. The sensing coil detects this and, in a tiny fraction of a second, the trigger mechanism will operate and open the contacts. Both contacts open, the line and the neutral, the current drops to 0 amps and the voltage to the circuit drops to 0 volts. The circuit has been put into a condition of safety. We should investigate the problem, remedy the problem and, in this case, buy a new kettle, and then reinstate the circuit. If you want to know more about how RCDs work, we have a very much more detailed video, and we will leave a link to this in the description to this video. There are important differences between RCCBs and RCBOs. A healthy 30 mA RCCB must have tripped at 30 mA or above. The actual trigger range is between 15 mA and 30 mA. It will only trip with earth currents, which cause the difference between line and neutral. The RCBO works as above. It will trigger on earth currents, but it also has the ability to trip when it detects overloads and short circuits, when line and neutral are the same value but exceed the preset limit of the device. Because the RCCB cannot detect overloads and short circuits, it must be installed with a separate MCB that will perform this function. The RCCB detects earth faults. The separate MCB detects overloads and shorts. On the subject of shorts, a short circuit is between line and neutral and nothing to do with the earth. If the problem is between line and earth, then it is called an earth fault. It is not called a short. The RCBO already has the functions of an MCB built into it. It is a standalone device that works as an RCD and an MCB. If we look at a typical RCCB, and this one shows 80 amps, 30 milliamps on the front, what is this telling us? 80 amps is the working current. It will pass 80 amps without damage to itself, 7 days a week, 24 hours a day. But this is not tripping current. Even if the current went up to 100 amps or more, it would not trip if the line and neutral were both the same. There is no protection for this, and the device may be damaged. And 30 milliamps is the tripping current for earth faults. A difference between line and neutral of 30 milliamps will cause it to trip. With an RCBO, things are different. Here we have C6 and 30 milliamps. This shows that the device is a Type C 6 amp circuit breaker with 30 milliamp RCD protection. This RCBO will trip when the line current exceeds 6 amps by a set amount, even if the neutral is the same value. And it will also trip if the line and neutral difference is 30 milliamps or more, an earth fault. So, in summary, the term RCD is the name of a family of devices. Often, an RCCB is called an RCD, and this is just one of those things that we have to become familiar with. If you said RCD to me, I would assume you meant an RCCB. An RCCB only offers earth fault protection and is sensitive to milliamps of fault currents. An RCCB must be installed with a separate MCB for overcurrent and short circuit protection. An RCBO provides earth fault and overcurrent protection in one device and does not need a separate MCB. Well, we hope that you found this video useful and informative, and in the description to this video we will leave links to other LearnElectrics videos that you may find useful. Thank you for watching this video. It is very much appreciated. Please subscribe to our channel to get access to all of our videos, and remember to click on notify to be sure of not missing our next video. Here are some tips on getting even more information and help out of LearnElectrics.com. At your web browser, enter LearnElectrics.com into the search bar, select LearnElectrics.com from the choices offered, and the website, as shown, will open up for you. You now have a couple of choices. You can search for a help item or any video by entering a keyword into the search bar on the right. Click on Return and all the help files and videos with that word in the title will be listed for you. They will be shown with a short description, and each video listed will have a link shown that will take you directly to that exact YouTube video. Or you can browse through a list of all the available items and videos. To do this, click on the LE logo on the top left of the home page and all our items and videos will be shown. There will be 10 items shown on each page, and at the bottom of each page is a page selector. Page 2, page 3 and so on. They will bring up the next 10 items or videos in the list. And don't forget, You can also type in LearnElectrics, all one word, into the YouTube search bar to go directly to our channel at any time from any computer. We are constantly adding new videos to our channel. Don't miss the next one. Once again, thanks for watching, and we hope to see you again very soon.